So I showed you guys some very nice tools that we could use, including a slicer and including a timeline. So I believe what I had you guys do is using the Pledges workbook. Is that correct? That's what I had you guys do. Using the Pledges workbook, please do the following. By fund name, show a count of pledges, the amount pledged and amount owed. Add donor type to the rows as well. And God bless you. Make fund name a slicer, make date pledged a timeline, find an appropriate report layout. So if we go to pledges and we open that up, we go to the pledges. We want all of this to be a pivot table. So I'm going to highlight all my data, do insert, pivot table, and we have a working canvas. So let's go back. It says it wanted, again, it wanted by fund name show a count of pledges. So we want fund name to be over here on the rows. So we have only 4 funds: the Bird Sanctuary, the Children's Zoo, the General Support, and Zoo Mobile. And wants count of pledges. So because I'm just counting, it really doesn't matter what I drag over here because it's just going to count it. So I'm going to, I don't know, I'll drag over donor name because it's numeric, it's going to count it. So it looks like I had 4 pledges. Is that all I have? Is 28 pledges? Yeah, this is small. So I have 4, 11, 7, and 6 respectively. But it also wanted to know the amount pledged and the amount still owed. So we're going to drag amount pledged down here and amount owed below there. So if I can drag that and drop it. So some of amount pledged, some of amount owed. So the Bird Sanctuary, we had 4 pledges. They pledged total $1,375, but we still haven't collected $550 of that. If I wanted to pretty that up, obviously under design, there's different styles I could use. I would probably also want to do because this is money, what would I want to do? Yeah, I would probably do field settings, go to number format, change it to currency, and probably don't need cents there. And I would do the same thing with amount owed. So I'd probably change that from sum of amount owed to amount owed or amount pledged to make it look a little bit nicer. I also asked you to add donor type to the rows as well. So that should be a simple thing. Take the donor type, drag it under the fund name. So now we know Bird Sanctuary, individual and organization, 3 versus 1. We have the totals for all those things. And then we wanted to provide this to someone so that they can interact with it. And according to that, we can make fund name a slicer. So we're going to go to Analyze, Insert Slicer, add fund name. So now it is a slicer that we can filter out things if we like. And I can also make that slicer match my table so it's the same color. And we also want to add to that same pivot table a timeline. And it's only for years or date fields. So we're going to do pledge date. Going to change it to, let's change that to years. I guess it's all in the same year, so it doesn't make sense. And we can make that timeline match as well. So, hopefully you guys get the gist of this, right? This is something, we'll come back to doing this. We're going to move on today to probability. But I think this can be very useful to you when you're presented a lot of data and need to analyze it quickly, right? And that's going to happen to you. Someone's going to say, make sense of this. We dumped all the transactions for the last 10 years. Make sense of this. Or, this is our customer base. Tell me who are our most profitable customers. Or how many males and how many females do we have? And when did people buy and not buy? And this is the tool you can use to analyze that data pretty quickly. So any questions on the pivot table? Okay. So we are going to move on today to chapter 5. And chapter 5 deals with a concept that we all kind of intuitively know. And that is probability. So let's do this. Let's look at some probabilities And let's see if you guys can help me ascertain what these are. So probabilities. What is the odds of a winning ticket in the Powerball lottery? Does anyone play the Powerball lottery? No one? Alexis? What is the odds of winning? Do you know? 1 in, what is it? Yeah, it's like 1 in 292 million. So if you think about it, you know, there's about 320, 350 million United States citizens. So your odds are almost the same as being randomly selected by like Obama to be the president, right? Or to be like his dinner guest. So that is not very likely to happen. And in fact, if you look statistically at like accidents, you know, like deaths per miles driven, if you drive, oops, I skipped one, I don't want that. Odds of getting killed driving for your Powerball ticket if you drive 1 mile to get it. What do you think that is? Yeah, if you drive just 1 mile round trip, like boom, boom, the odds that you die going to get that Powerball ticket is 1 in 80 million, so almost 3 times as high that you die getting that Powerball ticket and win the Powerball. That's kind of depressing, isn't it? How about this? And I kind of spoiled that, but you guys watched the debate? You guys watched the debate Sunday night? Yeah? Okay. No, you didn't watch it? No. Good entertainment. It's like, I don't know, it's all right, I guess. It's kind of deflating the whole thing. But, what's the odds right now? You know, there was that the Tape Gate thing, you know what I'm saying, about Donald Trump. The locker room talk, you see that? They don't talk like that in your locker room, do they? They don't talk like that in your locker room. You don't talk.
No.
That's not how locker rooms
No.
talk. That's not how. Anyways, odds that Hillary Clinton will be our next president. What do you think it is? 82%. If you go to a site called 538.com, if you guys ever saw that site, it's a guy named Nate Silver. He predicted every state correctly in the last presidential election and the one before, and every Senate race correctly by using polls, right? Inferential statistics. He predicted every state correctly, and they do like a lot of iterations. And right now, you know, the odds change over time, but right now it's 82% Clinton, and it's like, you know, there's like 14, 16% Trump, and then like, you know, 2% Johnson or something like that. So it's almost, the cake is almost baked is what I'm saying. That's pretty high odds, right? That's pretty high odds that unless something traumatic comes out, I think it's done. I really do. Other things, odds that you do not have a TV. So these are lifestyle odds. Odds that you do not have a TV. Only 2% of Americans don't have a TV. Odds you would get some serious form of food poisoning this year. How many people get food poisoning in a year? What do you think? I don't think I've ever had food poisoning. I have like an iron stomach. It's like 1 in 25, like 4%. I don't think I've ever had food poisoning. Odds you will start a diet this year, 1 in 5. Odds that you have or will have a problem drinker in your family. Everyone has that uncle, right, Mitchell? About 40%, right? About 40%, 2 in 5. Odds that a person will become an alcoholic sometime in his or her lifetime. This is kind of sad. What do you think? 1 in what? 1 in 4, that's pretty high. 1 in 18, so statistically, one of you. Percentage of drivers on the road after midnight on a weekend, they're illegally intoxicated. About 4%. Odds that someone uses pot, and this is like college age, 1 in 10. Odds that you're addicted to heroin, 1 in 500, that seems high. Other household things, odds that you will crush a finger with a hammer this year, about 1 in 3,000. Odds of finding a 4-leaf clover, about 1 in every 100,000. Odds of being seriously injured on your Christmas decorations this year, about 1 in 65,000. Odds that a high school footballer will make it to the pros, about 1 in 2,500. Odds that you make it to a college team, 1 in 20. Odds of a hole-in-one, 1 in 30,000. Odds of a double eagle, that's 300 par. That's called an albatross. That's like even rare, 1 in a million. Odds you will injure while playing ping pong. I'm very good at ping pong. I got it in my table. Play 1 in 9,500. Odds will be injured while playing billiards, 1 in 5,000. Bowling, 1 in 1,200. Baseball, more dangerous, 1 in 70. Basketball, more dangerous, 1 in 40. Football, the most dangerous, 1 in 30. Odds that an unmarried 18-year-old will never marry. Ever marry. about 5%. Odds of being struck by lightning, about 1 in 600,000. Odds of being injured or killed in a single trip on an elevator, it happens. Not likely, 1 in 17 million, but it happens. Odds of being eaten by a shark, 1 in 50 million, it happens. Odds that a random dream will be a nightmare, about 1 in 1,500. Odds that a high school graduate will live in poverty, just a high school degree, no college degree, about 11%. However, if you have a college degree, what happens to that percentage? It goes down, it's about 3%. So it can still happen, but it's less likely. That's called conditional probability. Odds of a person 35 to 44 who has a high school degree only reports good health. So I'm above that demographic now, which is awful. But 35 to 44, so like kind of middle age-ish, who has a high school degree reports good health, like they're healthy, about 55%. But if you have a college degree, what do you think percentage in that same age group reports good health? It was up to 83%. So not only, more likely to be in good health, not because you'll take care of yourself, maybe wellness is a component. There's all kind of things, higher education-wise. 35% smoke if they have high school, only 20% with a bachelor's. 49% vote if they only have a high school degree, as opposed to 75% if they have a bachelor's. You're more likely to donate blood, you're more likely to volunteer. Even your children are more likely to do well because you have a college degree, you're more likely to exercise, and you're more likely to be happy. So one of the reasons why you decided to get a college degree, hopefully, was because you wanted to improve the odds of these kind of things in your life, right? How about St. Francis University? Odds that an applicant is accepted. What? 70? Pretty close. 77.5%. So we're not really like just pulling the cream of the crop, right? 4 out of 5 are accepted. Odds an SFU student receive some form of financial aid. Pretty high, 94%. My sister is a professor at Bucknell. 2/3, and they're really expensive, like $60,000 a year, $65,000 a year, something like that. One of the most expensive schools. 2/3 of their students get no aid. None. They write the check for $65,000 every year. Yeah. So ours is very, very high, obviously. Yeah. So a lot different kind of thing. Odds an SFU student is a female. What? 60. Like 2/3, 66%. Odds an SFU freshman stays at SFU. What's our retention rate? All colleges track this. 84%, which is pretty good. Odds an SFU freshman graduates in 4 years or less from St. Francis. Only 60%, right? Because people that transfer out count against us. People that take that extra semester or summer classes. 5 years or less, only 70%. Okay, because people that transfer out. Odds an SFU alumnus will donate back to SFU. What's our donation rate? What do you think? Don't one of you guys work at the alumni office? Do you? What do you think? You probably have the best insight of this. Do you call people and like, hey, will you give us money?
No, I actually process all of this.
Oh, okay. 17%.
Wow.
SFU students Catholic, about 60%. White, about 83%. Student athletes, in school business it's high. It's like 75% or so in school business. Overall, though, it's like 36%. If you look at health sciences, they don't have any student athletes. Odds and SFU students from Pennsylvania. Huh? It is. It's 72%. Odds an SFU student graduating in the top 20% of their high school class. 46%. Odds an SFU student enjoys Dr. Miko's stats class. Yeah, of course, 100%. So think about that. Those are probabilities, and we gave those in a couple ways, right? We gave them either as 1 out of something, okay, that's a ratio method, or a percentage, right? And it allows us to encapsulate and understand something. And that's why we're talking about in the world of statistics. And the reason we talk about it in the world of business is because probability helps us make decisions, right? If we know something is likely to happen, well then maybe we make a decision based on that event is likely to happen. If we know it's not likely to happen, maybe we make a different decision, right? We want to know the impact. And that's called risk, like trying to predict out in the future. So I need like, let's see, 4 volunteers to come up here. 4 volunteers. Mitchell Boyd, come on up. Stefan, come on up. Eric, come on up. We need a female. Sophia, come on up. All right. So I'm going to hand you, and these are pretty cool, a die. There's 4 die here, right? So each die is different. This is the standard die that you've probably seen in your life, 6-sided die. This is an 8-sided die, which is pretty cool, 8 sides. This is a 12-sided die, which is cooler yet. And this is a 20-sided die. So you can roll one of 20 things. So you guys are all going to get the opportunity to pick one of these die and then roll it. And if you roll your number, I will give you a bonus point. A handshake, which would be good for. So pick your die. All right. So Mr. Boyd is irrational. We know that right now. Go ahead. Stefan is not irrational. And Sophia just gets stuck with the flesh.
What happened to ladies first? Jeez.
Yeah, what happened? There's no gentlemanly here. So, Mr. Boyd picked, what did you pick, the 12-sided die, Mr. Boyd?
Yes.
Why did you pick the 12-sided die?
Because I wanted to pick 7.
You wanted to pick 7. All right. So that is not rational, right? Why not? If you were making this
Because I had
decision.
it clear up there.
No, but why was your decision not rational?
Oh, because I don't know.
If you were making your decision rationally based on statistics, Stefan, what should he have done?
More probability.
Yeah, because what's the odds that your 7 comes up? And I hope it does for your benefit.
1 in 12.
1 in 12, right? So it's like 8%, okay? If you'd have picked Stefan's die, it's 1 in 6, right? So go ahead, roll your die. Oh, sloppy.
7.
3, all right, go sit have a seat, Mr. Boyd. So you lose. Stefan he chose second, and he didn't care about the color of the die. He didn't care about his lucky number 7. He didn't care about anything. He went immediately to this die. And why did you choose this die, Stefan? Because it's a better chance, 1 in 6. So pick a number and roll that die.
5.
Okay. And you have 1. No good. Okay, let's go to, you have a 12-sided die or 8-sided die, which is pretty cool. So you got a 1 in 8 chance.
I don't know. It's 20 to 3.
He's going with a 3.
Use my volleyball number.
1. I don't think that even rolled over.
Don't pick that number.
It's like slid
What
that
number
thing.
should I pick?
Reroll.
So she's got a 20-sided die.
The high one.
No.
16, something like that.
16.
No, don't do that one because I'll be late.
Nope, 16. I don't get it. It's your fault.
Yeah, well, you already said it.
16.
Wait, do I get bonus points too?
No, I get bonus points.
So what was the odds? Sophia did. She nailed it. What was the odds that she got that right then? What was the odds of that happening? 1 in 20 or 5%. Okay, so people sometimes interpret probability. And I'll give you a bonus point. Sometimes I don't think I've ever lost that game, so that was the first time I've ever made a bonus point. So people interpret probability that way, like 5%, it's never going to happen. Not true, right? It happens 1 out of 20 times. But we use probability to make decisions, right? Not always do we make decisions, because if we just made decisions based on probability, we would never go and buy that lottery ticket, would we? No. Other things we would never do, we would never gamble, right? The odds are stacked in our favor or against us. We wouldn't buy insurance. So there's all kinds of things that we would not do. So let's go to the material, the course material, and kind of define some things associated with probability. And there's some terms and some things that I would like you to know. Okay. So first, we're going to talk, and it's not in the slide, so I'm going to have to use the board. When we talk about probability, the first thing we start is we talk about something called a random experiment. A random experiment is, as the name implies, it's an experiment that happens. I'm going to pass these diagrams if you guys want to see a 20-sided die. Cool. It's something that occurs that we don't know the outcome. We flip a coin, that's a random experiment. We play a game, that's a random experiment. We make an investment, that's a random experiment. We make a decision, that's a random experiment. So anything that we do that has multiple outcomes that we don't know what's going to happen is called a random experiment. Now, the way that we denote the outcomes is something called a sample space. And a sample space is, we do in set notation. So set notation looks like this. You know, those squiggly brackets, you guys have seen set notation. So the sample space for a roll of a six-sided die, what are the possible outcomes? Looks like this. 1, 2, 3, 4, 5, 6. We're going to play a football game this weekend against who, Mr. Boyd? Who are we playing this weekend? Bryant. What are the outcomes of that football game for St. Francis University? What is it? Win? Lose? Can you tie in college still?
I don't know.
Huh? No, I don't think you can anymore. So there's only two outcomes, okay? Win or lose. If I do something like make an investment, we might say, well, the investment has all three outcomes, goes up, stays the same, or goes down. Okay, so a sample space is just the process of delineating all the possible outcomes. Now, a couple things. Okay, we refer to these things as outcomes, and further, we refer to them a couple different ways. If it can't be broken down any further, like we can't break it down any further, we call it a simple event. So for example, rolling a 1 is a simple event because it can't be broken down any further. Rolling an even number is an event because it's comprised of three simple events. Rolling a 2, rolling a 4, and rolling a 6. So simple events and events are different things. Events can be comprised of simple events. Okay? If we're talking about hockey where there are ties, right? Win, loss, and a tie in a hockey game, not losing is called an event because you can either win or tie. Okay? So if it can be broken into, it can't be broken down any further, it's a simple event. If it can be broken into several simple events, it's an event. A couple things that go along with these outcomes, and I'm not sure if this is in the slides or not. No, it's not. So when we talk about these events, there's two things that go along with them. The first one is all the events need to be mutually exclusive. What does that mean? Mutually exclusive. Have you ever been in a mutually exclusive relationship? Kyle? Yes? What does that mean if you and your girlfriend are in a mutually exclusive relationship? Okay, you date her to the exclusion of everyone else, right? So when we look at a sample space, we say these events are mutually exclusive, meaning there's no overlap. If you roll a 1, you can't roll a 2, 3, 4, 5, or 6, right? If you win, you can't lose. Does that make sense? If it goes up, we're eliminating those things. So all the events in an outcome are called, in a sample space, are called mutually exclusive, meaning there's no overlap. If one happens, it excludes all the others. If you date this girl, you exclude all the others, right? The other word that goes along with this is exhaustive. And what exhaustive means is it includes all the possible outcomes, any possible outcome. So if this were the sample space for an NHL hockey game, this would not be exhaustive because the Penguins on Thursday, they play on Thursday, they could win, they could lose, or they could tie, right? So now it's an exhaustive sample space because it includes all the possible outcomes. So every sample space, the outcomes need to be mutually exclusive, no overlap, and they must be exhaustive. Now, what does that look like mathematically? Well, mathematically, it looks like this, okay? Mathematically, we draw it this way. If we're talking about the probability of an outcome, okay, probability of an outcome, that's how we write that. The probability of this occurring is always between what two values? Probability of something occurring is always between what two values? 0 and 1, right? So because it's 100%, 0 to 100%, it's always between 0 and 1 or 0 and 100%. 0 and 1 or 0 and 100%. I'm going to do percentage. Also, if we sum up all the probabilities associated with the sample space, what do they sum up to? Always. 100%. Okay, so we're going to be able to use these rules in our favor, right? This is the mutually exclusive and exhaustive nature of probabilities. So those are just some rules, some things that go along with probability. But when we define probability or assign probability, there are three approaches we can go with to assign probability. The first one is something called the classical approach. And that's what we use when we guys assign probabilities to the die. So when I handed you the 20-sided die, you said the odds of that occurring is 1 out of 20. How do we know that? Well, there's 20 sides. Each one is equally likely to happen, so 1 out of 20. Classical approach is when it's like a mathematical thing, rolling a die. What's the odds that I pick the jack of spades out of a deck of cards? Well, there's 52 cards. Each one is equally likely to happen, 1 out of 52. Does that make sense? So that's called the classical approach. Anytime it can be mathematical, it's called the classical approach to assigning probability. The second approach, which we use oftentimes, is relative frequency approach. Okay? And if you want to think about it, it's more like an historical approach. So, for example, we said, what's the odds that an SFU student that enrolls in St. Francis is female? We might say 66%. And where do we get that number from? Well, we look back historically over the last 5 years, and 66% of students that enroll historically were female. So we're saying the odds that a given student enrolls that is female is 66%. If I say the odds that I look back historically and only 1 out of 100 people have failed STAT302, so I say the odds that you fail STAT301 is 1%. That's called the relative frequency approach, right? Looking back at the past to assign a probability to the future, okay? And the last one is called the subjective approach. So the subjective approach would be assigning a probability based on your expert opinion. I think that the odds that we beat, who are we playing again, Mr. Boyd? Albany? Bryant. The odds that we beat Bryant this week, based on my knowledge of the teams, is 90%, right? That's just my expert opinion applied to that. If you listen to an economist and they say the odds that the economy goes into a recession is 50%, that's his or her expert opinion, right? That's called the subjective approach. Does that make sense? Okay, so the first thing that I'd like to do is, I gotta get my book. Does anyone have their book handy I can project? Not my book. Anyone? No one brought the book? Thank you, Malik. So let's do a couple of these. And this is easy stuff because I know you've seen probability before, but we have to do the easy stuff before we get to the hard stuff. So let's look at chapter 5. And I would like you to do, so just take a few minutes. And I would like you to do number 2 and 3. Okay, can you guys see that up there? It's too small? Better? Okay, so let's look at this one. It says 4 candidates are running for mayor. The 4 candidates are Adams, Brown, Collins, and Dalton. Determine the sample space of the results of the election. Employing the subjective approach of political science to assign the following probabilities. Okay, so first, if it asked us to delineate the sample space, and we're going to do that in set notation, what does that look like? What are the possible outcomes? Very good. So the first outcome is Adams wins. And I'm just going to abbreviate the rest. B wins, C wins, and D wins. Okay, that's the sample space. Mutually exclusive and exhaustive. Employing the subjective approach, a political scientist has assigned the following probabilities. Why the subjective approach? Because what? Because the political scientist said, based on what I'm seeing, based on his expert opinion or her expert opinion, that's the probability she came up with, right? That's subjective. If I said I'm going to put all 4 names in a hat and randomly pull one, and that's who wins the election, what approach is that to assigning probability? Classical, very good. And if I say, looking back historically, maybe Adams is the Republican candidate. The Republican candidate has won 80% of the time, so I'm saying 80% of the time Adams is going to win. What approach would that be? Relative frequency, very good. Okay, so gives us these probabilities. So we have 42%. We have 9%, we have 27%, and we have 22%. Determine the probabilities of the following events. Adams loses, okay? So what's the probability that Adams loses? First of all, is that an event or a simple event? Let's talk about that first. Is Adams losing an event or a simple event based on the way we have our outcomes defined? What do you think? An event or a simple event? A simple event means it has to be up here. It has to be one of these. We don't have any Adams losing here, but where does Adams lose? What happens? Where Brown wins, where Collins wins, and when Dalton wins. So it's comprised of 3, what? 3 simple events. So it's an event or a simple event? It's an event. How do we figure out the probability then Adams loses? We add up the probability of all the simple events that comprise that event. 9% plus 27% plus 22%. That gives me, what does that give me? 58%. Okay? Anyone arrive at that a different way? Anyone get that a different way? Mr. Boyd? Okay, very good. What Mr. Boyd just learned, or not just learned, but just deduced, is something in the statistical world we call the complement rule. The opposite of Adams winning is Adam losing. So we say 1 minus the probability of Adams winning, 1 minus 42%, that gives me 58%. That's called the complement rule, right? 1 minus the opposite of that happening is the odds that that thing happens. Either Brown or Dalton wins. Is that an event or a simple event? Brown or Dalton wins. Because it's comprised of 2 simple events, it's an event. Brown or Dalton wins. That would, we add these 2, 9% and 22%, and get 31%. Either Adams, Brown, or Collins wins. We would add those 3. We add these 3, and we get, I think that's come up to 78%. So, I know that was easy. I know you've dealt with probability before. But let's talk about some things that make it a little bit more fun, easier to deal with, or maybe more exciting to deal with. So we're going to talk not just about simple probability, because it's pretty straightforward, but we're going to talk about what happens when we combine multiple events. And there are several types of combinations and relationships we're going to talk about. The first one is a complement event. A complement event, as you guys know, is the opposite of something happening. We just deduced that. Intersection of event is like an and situation. A union of events is an or situation. Mutually exclusive events means opposite of that happening. And we're going to talk about dependent and independent events. So first, the complement of event. A lot of times we use Venn diagrams to show this. The complement of an event A is defined to be the event consisting of all sample points that are not in A. And the way we denote this, and this is important, is if A is the probability of, is A happening, A with a superscript C is the opposite, right? So the probability of winning complement is actually the probability of losing, right? C means, the complement means the opposite of that thing happening, right? The superscript C means the opposite. The Venn diagram below illustrates the concept of that complement. Because there's no overlap, because they always have to add to 1. A plus A complement is equal to 1. The intersection of two events, if you think about it, that's an and situation. The odds that I'm late for work and you're late for class. The odds that it rains outside and the game is canceled, right? It's when both things occur. So if we look at a Venn diagram, we call that an intersection. We also call it a join, and it's where A and B overlap. Okay, that's an and situation, an intersection or a join situation. And the way we denote that is with the letter and. I mean, with the word and. So the probability of A occurring and B occurring is an intersection. Union of two events is an or situation. So if we talk about the union of A and B, we're talking about the probability that A occurs or B occurs. Okay, so it would be both of the circles. The probability that I'm late for work or you're late for class, right? It's more inclusive than an intersection, than an and situation. Okay? Mutually exclusive means no overlap. You know, we talked about that. We talked about probability length. If A and B are mutually exclusive, means there's no overlap. If A occurs, B doesn't occur, right? There's no overlap between those two, so the intersection of them would be 0. So those are the basic relationships of probability. Now we're going to move on to something called a joint probability table. And this is where you guys need to really tune in, because this is where it gets a little bit more difficult, right? The first stuff I know is pretty easy stuff, but this is where it gets a little bit more difficult. So oftentimes, we want to see if things matter, right? We want to see if, it doesn't matter if I go to college. Does that improve the outcome of my life? Does it matter if I invest with a top 20 mutual fund manager? And that's what we've done here, okay? So we want to investigate a relationship. So we went out, we looked at some mutual funds. You guys know what a mutual fund is here? Who's a finance major? What's a mutual fund? Any finance majors here? Someone I can go with the roster. Definitely, you're a finance major, aren't you? Yeah. Okay, what's a mutual fund? What's a mutual fund? You know what a mutual fund is. I'll tell Dr. P. They don't. What's a mutual fund?
Just bunch of stocks in
Okay, so a mutual fund is, I don't want to invest by my own stocks, right? So, because I don't have time for that. My expertise is teaching. I'm not an investment expert. So what I would do is maybe give my money to a place like Vanguard or Putnam or many other what they call mutual fund managers, and they hire a team that takes money from me, that takes money from Sid, takes money from Eric, and invests it all together, right? So we say, I'll give you $25,000, and this person gives us $100,000, and they invest millions and millions of dollars on behalf of their clients, right? Mutually, right? So we pull all our money together, and then if the fund does well, hey, we get a percentage of that return. If it does bad, we lose part of our money, right? So if the fund goes up 8%, we get 8%. They take some fees. And if it goes down 10%, we lose 10%. Well, they take some fees, so we probably lose 11%. Does that make sense? You guys know what a mutual fund is? So the real important thing is, I'm giving my money to someone to invest. So who's doing that investing, making those decisions is a real important decision, right? Like, would I give my money to just some random student to invest on campus? Probably not, right? So one of the things we want to investigate is who the mutual fund manager is. The mutual fund manager is the male or female that's making the decision on where I'm going to invest this money, what I'm going to buy, what I'm going to sell. And we want to see if it matters what MBA program they went to. And every MBA program has a ranking. Like Chicago, Stanford, MIT, Wharton. You guys have heard of these MBA graduate schools? St. Francis. We are not a top 20 program, but we're a good program, just outside the top 20. So top 20 MBA program graduate or not a top 20 MBA program graduate? And then did your fund outperform the market or not outperform the market? What does that mean, outperform the market? What does that mean, Kyle?
You did better than like the market average.
Okay, so outperform the market means not just did your stock, your mutual fund go up, but let's say the market overall went up 10%, but your fund only went up 8%. Is that good? No, you didn't beat the average, right? Outperform the market. And counter, if the market went down 10%, but your fund only went down 6%, did you beat the market? Yeah, so you outperformed the market. So that's how they're evaluated. Like, not just did it go up or go down, but did you beat the average? You know what I'm saying? Did you beat the average? So what we did was we asked 100, let's say 100 mutual funds, and we asked them 2 questions. We said, did your fund outperform the market last year? And are you a top 20 MBA graduate, yes or no? And based on that, we compiled what's called a joint probability table. So these numbers represent and situations. They represent joins of the table. So if we look at this, and I'm just going to replicate this table up on the board, there were 11 of the 100 that were from a top 20 MBA program, and their fund outperformed the market. Okay, 11 of the 100 or 11%. There were 6 of them that weren't from a top 20 MBA program, but their fund outperformed the market. There was 29 that did not outperform the market, and they were from a top 20 MBA school. And there was 54 that were not from a top 20 MBA school, and their mutual fund did not outperform the market. What I've just created up there is called a joint probability table. So the table represents joint. So if I asked you to read this table and I said, what is the probability that a given fund is managed by a top 20 MBA graduate and didn't outperform the market? What would you tell me? Go ahead, what'd you say? 29. All you do is read the table, okay? Anytime we get a joint probability table, our first step is to add down the columns and across the row. So I'm going to do that. 11 plus 6 is 17%. 54 plus 29 is 83. This is going to be 40. This is going to be 60. If you notice, 40 and 60 add to 1, 17 and 83 add to 1. Those probabilities I just figured out are called marginal probabilities, and they represent overall probabilities. So what percentage of all funds, period, outperform the market? I need to look into the margin for 17%. What percentage, what's the probability that a given fund is managed by a top 20 MBA graduate, period? From a top 20 MBA graduate, you look in the margin, that should be a 0. 40%, right? 40%. Does this make sense? All right. Now, what am I really concerned with, though? So I know these, but what is the thing I'm trying to answer with this analysis? I didn't answer it yet. What is the thing I'm trying to answer with this analysis? What do I want to know? Eric, go ahead.
Likelihood of results based on who you're investing with.
Okay. So he's right. He's saying, does it matter who's managing my funds, right? Like, what I want to know is, does it matter if the person managing my funds is a top 20 MBA graduate or not? Does it matter? Does it change the odds, if you will? When we talk about that situation, we're talking about something called conditional probability. And this is how we write conditional probability. Okay, this is like a bar, just like a line. Remember, intersection is and, union is or. If we see a bar, we read this as given. This is the probability of A occurring given that we know B. This is the probability of A occurring given B is known. Given that B is done, right? B is the known situation. If probability that you live in poverty, given that you are a 4-year degree, is 3%. That's a conditional probability. Okay? Conditional probability is given a condition, what is the probability of that event occurring? So I want to know the probability that a given fund outperforms the market, you told me, is 17%. Right? Overall, all funds 17%. You guys with me? I want to know what's the probability a fund outperforms the market given that it's managed by a top 20 MBA graduate. I want to know if it goes up, if it goes down, or if it doesn't change. Does that make sense? I want to know what's the probability of it outperforming the market given it's from a top 20 MBA school. Does that make sense? No? Yes? All right. So how do we do that mathematically? Anytime we have a conditional, we do the same thing. Whatever these two events are in here, our numerator is the join of the two. Always. It's a positional formula. So whatever these two events are, we're going to join them together. That's the numerator. Does that make sense? If this was the probability of apples given oranges, our numerator would be the probability of apples and oranges. In this case, it's probability A given B. It's probability of A and B together. Divided by the probability of the condition. All right? So the conditional probability is the join of the two divided by the probability of the second. So let's take a look at this. Let's see if we can figure this out. The probability of outperforming the market, given that it was managed by a top 20 MBA school, we're going to join those two. That's what it says to do. Always join those two things divided by the overall probability of the second. It's a positional formula. So let's go back to our table. What's the join of these two equal? Outperform and top 20. Where do they intersect? What's the number that correlates with this? 11%, right? Top 20 outperforms the market, 11%. You guys see that? What's the probability that it outperforms the market? Or, I'm sorry, probability it's from a top 20 MBA school overall? What's that? 40%. 11% divided by 40% gives me 27.5%. I can answer now, does it matter? So Eric, let's go back to our question. Does it matter? And why?
I guess it does.
Let me frame it this way, Eric. What if we don't know anything about who's managing the fund? What's the odds that the fund outperforms the market, beats the market overall?
The 17%.
Right. If we know the fund is managed by a top 20 MBA graduate, what's the probability it outperforms the market?
The 27.5%.
It went up. It matters. Because they're not equal, because it matters, we call those events dependent events, meaning it changed things, right? Dependent events. If they were equal, if that stayed 17%, we would say they're independent events, meaning they don't matter. They don't influence one another, but it definitely does influence one another. Okay, we don't have much time, so let's do one really quickly. I'm sorry. I don't want to rush you, but let's do one before you leave here. Let's do number 5. And I'll give you just like 2 minutes. So if you can knock it out in 2 minutes, great. If not, we'll do it together. So discrimination in the workplace is illegal, and companies that do so are often sued. The female instructors at a large university recently lodged a complaint about the most recent round of promotions from assistant professor to associate professor. Analysis of the relationship between gender and promotion produced the following joint probabilities. All I want to know is there discrimination going on at this university? Pretty good. Okay. So what do we do? The first step when we get a joint probability table is do what? What did I tell you we do? Add down the columns and across the row. So this is 20%, this is 80%, this is 15, this is 85. If I did this right, and I did, they should add to 1 or 100%. What's the odds that someone at this university is promoted, period? Overall, what's the odds that someone is promoted, period? Odds of promoted is 20%. The odds that someone, given a random person, promoted is 20%. I want to know if gender matters. So I want to figure out if the probability that someone's promoted changes given we know that they are a male. Okay? I want to know the probability of promotion given that they are a male. What did the formula say to do to figure that out? What do I do with those two events? I join them, right? Where do they join? 17% divided by the probability of the second, which is male, which is 85%. If I do that math, it gives me 20%. At this point, I can answer the question, is there discrimination going on? Is there discrimination going on, Jonathan?
No.
Why not?
Because it's only 20%.
Okay, so
Which means that it's not over 50%.
your answer is right, your logic's not. It didn't change, right? The overall odds that someone, we don't know their gender, is promoted is 20%. If we know they're a male, guess what? Stays 20%. Didn't go up, didn't go down. So if we figured out the same thing, the probability that you're promoted given you're a female, let's see, let's join the two. That's 3%. Divided by the probability that you're female, it's 15%. That's also 20%. So gender doesn't matter. So because gender doesn't matter, because they stayed the same, we call those events independent or dependent? Independent. Okay. So here's what I'd like you to do for homework for Thursday. I would like you to do, we did 5, so I would like you to do, oh, you guys can't see this. I would like you to do 6, 7, 9, and 10. 6, 7, 9, and 10. 6, 7, 9, and 10 in chapter 5. Okay. And I will see you on Thursday. Oh, no, I won't. I'm going to Pittsburgh. Yeah. I love that. Like, you won't see me for a week. Yeah. Awesome. That is, I'm human, I have feelings. Maybe I'll record a lecture. Check your email, but there won't be a face-to-face.
We don't have the next Tuesday.
Huh?
We don't have it next Tuesday.
Oh, wait a minute.
Yeah.
Next Tuesday's midterm break. That's a long time without Pico. What? Oh yeah, thanks for letting me borrow that, Malik. I forgot about it too. I check your email. I got to do something. We got to stay fresh.